Okay, hello everyone. So today we're going to start with a new topic called binomial theorem. Okay, and I think a lot of people's impression about binomial theorem is that it's very difficult. I don't understand what's going on. But to be honest, binomial theorem is actually a very powerful theorem, and because it is very powerful theorem, right? Like it's at a very abstract level. Yeah, so to speak, it's a very abstract level. So and also because of that, a lot of people like try fear what is binomial theorem, but actually, right, it's not so bad. Okay, let me assure you that it's actually not as bad as you think. Okay, now, because right, binomial theorem actually comes from the motivation that what we did in sec two, right? In sec two, what we did was we expand a plus b squared, right? So we are actually looking at expanding a plus b, two terms, right? So binomial theorem, the bi means two, nomial means terms, right? So how do we expand two terms? So previously in sec 2, we talked about a plus b squared. So what is this? This is just a squared plus b squared, and we don't forget our 2ab. Okay, so we are actually looking at how to expand things with a higher power. So we are looking to expand a binomial a plus b, but raised to the power of n. So this is the motivation of this chapter. Okay, then the second thing that we want to see that is because binomial, when we expand, right, after we do the full expansion, it may be very long, it may be very, going to be a huge answer. Okay, so it will allow us, the binomial theorem will allow us to find a specific term for the expansion. So we don't have to expand the full thing. We can make use of the theorem to just zoom into just one of the terms. Okay, and this is a very very powerful theorem that will allow us to take a giant task, okay, and just get the formula to go there directly. Okay, so this is the beauty of binomial theorem. Okay, now, but before we start this binomial theorem, right, I'm going to go through three elements, right, of surrounding this binomial theorem, so that when we start to expand things fully, we can see how these three things work together for the expansion. Okay, okay, so let's start off with 6.1. 6.1, we are going to talk about three things. I'm going to talk about this exclamation mark, and I'm going to talk about this bracket thing over here, right? And these are actually two new notations that we are going to learn. Okay, and the third thing is just a bonus that will help us to make sense of the expansion later. Okay, so the first one that I'm going to introduce you to you is this one. Okay, now what is this actually? This is what we call, okay, we pronounce this as n factorial. Okay, we pronounce this as n factorial. Okay, so what is actually n factorial? What does it really mean? It actually is the number of ways, right? The number of ways to arrange n items. Okay, so let's build up our knowledge about this. So let's go with this one over here first, right? So what on earth is 0 factorial? So what are the number of ways to arrange 0 items? So actually there's just 1. Okay, so we define 0 factorial as equals to 1. Okay, so this is a chosen number, because technically speaking, the number of ways to arrange no items is just one way. There's just no way, so it's just one way. Okay, now then what about number of ways to arrange one item? So this will be just 1, right? The number of ways to arrange 2 items, so let's say I have one item A, one item B, so it can be A, B, it can also be B and A, right? So there are actually 2 ways of doing so, right? Then what about 3 items? Now 3 items is the one worth talking about. Okay, so now let's say we have ABC. So how do we arrange ABC? Is it only 3 ways to arrange ABC? So we have ABC, right? We have ACB, right? We can start with B also, BAC, BCA. We can also start with C, CAB, and C, B, A. And I think this is all the possibilities, right? So how many ways can we do so? We have 6 ways. So actually 3 factorial, right, is actually 6 ways to do so, right? So but instead of like, like counting out manually how to do so, right, you can think of it in terms of like this, right? I have 3 slots. So for the first slot, how many choice can I put there? I have 3 choices to put there, right? The second slot, how many choice can I put there? I have 2 choices to put there. And the last slot, I will put the remaining one over there. So it's just 3 times 2 times 1, so it's just equals to 6 ways to rearrange. Okay, what about 4 factorial? So now what if I have 4 slots, A, B, C, D? How do I rearrange these 4 items, right? So the first slot, I have 4 choices. Then I multiply with the 3 remaining choices. I multiply by 2 remaining choices, and the last one have no choice, have to be there, right? So it's 4 times 3 times 2, so 4 factorial, right? So 4 factorial, okay, so 4 factorial, right, is going to be equals to 4 times 3 times 2 times 1, so this is going to be equals to 24. Okay, so 3 factorial, let me write it here, so 3 times 2 times 1, right, and this one will be equals to it equals to 6, like that. Okay, so enough of this, right? So technically speaking, right, there's a reason why I leave a gap up there, yeah? So technically speaking, what is n factorial? So n factorial means the number of ways to rearrange n items, so it's just n times n minus 1, n minus 2, and so on until times 3 times 2 times 1. Okay, so this is the meaning of n factorial. Right, we take n, multiply by the number decreasing and so on. So let's say if I were to look for 6 factorial, right? Let me give you another example. So let's say I have 6 factorial. So what would that look like? That would look like 6 times 5 times 4 times 3 times 2 times 1. So in our calculator, we actually, on the upper right corner, right, this one over here, beside the apps, right, so there's a factorial button. You can actually type in 6 and then type in the button over there. It will give you 720. So there's 720 ways to rearrange 6 items. Okay, so so this is the first notation, the factorial notation, right? And it tells us the number of ways to arrange n items. Okay, so this is the definition that we need to know, right? We need to know that 0 factorial is 1. Okay, and the next one that we need to know is we can also sometimes rewrite n factorial, right, as n times, and sometimes we have this, correct, all the way to 3 times 2 times 1, correct? Now, but the thing is that, like sometimes we can rewrite this as n minus 1 factorial, agree? It is like starting from n minus 1 and we count all the way back. So technically speaking, right, we can also write it like this. So n times n minus 1 factorial. Okay, so sometimes I can rewrite it like this. Okay, so this is like another result that we can use to help make our lives easier. Okay, so let's do this. Okay, so let's take a look at try 1, right? Try 1. So without using a calculator, evaluate this ungodly value. So 11 factorial and 8 factorial. So we can do this the full way, right? So 11 factorial over 8 factorial. So we can do this the full way. I can expand this times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I can do this, right? And then divided by, right, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I can do this, and then I see over here, I can cancel all this out, right? So it's just 11 times 10 times 9. Okay, so I can do that. Now, the other lazier way to do this, right, is to recognize that 11, right, is just this 11 times 10 times 9, right, and then times 8 all the way down, right? So technically I can just stop at 8 and put the factorial there. Okay, so I don't need to write out everything, right? So the factorial notation, right, is wonderful in the sense where we don't have to write everything out. It's understood that from 8 factorial onwards it's going to be the same thing. So what I have in the end is just a cancellation of these 8 factorials over here, right? So in the end of the day it will be just 11 times 10 times 9. So this answer would be 990. Okay, just like that, without using a calculator. But you can use a calculator to verify. Okay, without using a calculator means that we just want to do manually. Okay, now for B, let's take a look at this. Now B is a bit more abstract. We, instead of having fixed numbers, we will deal with unknown n, right? So let's take a look at this. So we have an n factorial divided by n plus 1 factorial. So actually n plus 1 is bigger than n, agree? Right? So when we expand the thing, I'm going to expand n plus 1 over there, right? So n factorial means n, n minus 1, n minus 2, all the way to 3, 2, and 1, right? And then the n plus 1 factorial, I can start with n plus 1, right? Then I multiply with n times n minus 1, n minus 2, n minus 3. Keep multiplying, right? But I'm lazy, so I can just stop it over here, right? And now I see that actually the top and bottom are the same, so I can just cancel this, cancel this. So this will be just simply 1 over n plus 1. Okay, so when we see things like that, we can actually make use of this form, like the factorial notation. Just stop there and then we just cancel. Don't have to write the whole thing. It's tedious to write the whole thing. So that's why like mathematicians they invent the factorial notation, because it's just a tedious thing to write all the way towards the end. Okay, so this is for try 1. Okay, so with the after try 1, I'm going to introduce you to the second thing. It's about this thing over here, right? So this thing over here, how do we pronounce it? This is actually n choose r. Okay, n choose r. Now what does n choose r mean? It actually means the number of ways, right? Number of ways to choose r objects or r items, okay, from a list of n objects. Okay, so it's like, for example, I have 5 bunnies. I have 5 bunnies over here. I just want to choose 3 of them, but I just want to find the number of ways to choose 3 of them. Another thing to think of is that in a class of 40 people, I only need to choose 4 class committee. So how many ways that I can do this is 40 choose 4, right? So this is the notation that we write: nr, n above, r below, and like in a bracket. Now another way to write this is another way to write this is nCr, okay, or another way to write this is nCr, okay, small n, c, and small r. Okay, so like that. So this is the n choose r thing that we need to learn in this part. Okay, alright. Now, so there is actually a formula for n choose r, right? The formula is actually like you take number of ways to do things, and that, so that will make sense once you go to JC. They will explain more for that. Okay, for us, I think right now we just need to know that it's a number of ways to choose r objects from n objects, but the formula is like this, right? So n choose r, okay, n choose r is just simply n factorial divided by r factorial times n minus r factorial. So this is the formula that we have, right, for n choose r. Okay, why isn't it boxing? Like, why is it? No. Okay, give me a box. No, not boxing. Okay, good. Now I have a box. Okay, like this. Okay, so now let's let me give you an example. So by the way, n and r, these are integers, right? N and r are integers, positive integers. Okay, and r must be a smaller number than n. Okay, so this one, let me do this. Okay, the condition is okay, so n and r are integers. Okay, n and r are integers, and then 0 less than r less than n. So it can be between, it can be like this. Okay, now without further ado, let me give you an example. So one example would be, what is the value of 8 choose 2? So on your calculator, there is on the divide button, right? There's the nCr over there. So you just shift divide to get so you still type 8, shift divide and 2, right? So you get the nc2 over there, right? However, if you want to calculate manually, right, so this is the way to do so. So 8 choose 2, okay, you can use your calculator, but let's say if they want you to not use a calculator and do manually, so based on the formula, I will have 8 factorial, right? I have an r factorial, means I'm going to have a 2 factorial at the bottom, right? And I have an 8 minus 2 factorial, which is actually 6 factorial. Okay, so I have 8 factorial, divide by 2 factorial and 6 factorial. So you can see that the 2 and the 6 at the bottom adds up to 8. Okay, let me give you another example. Let's say I have 9 and 5. Okay, 9 choose 5. So how would that look like? Would be, I have a 9 factorial over there on top. At the bottom, I'm going to have a 5 factorial and a 4 factorial. So 5 and 4 will give you 9, like that. Okay, so let us do like some manual calculation. Okay, so this manual calculation will help you when we have unknown n. Okay, so you will see like this. So it will be like 8 factorial, correct, times 7 times 6 factorial, and so on and so forth. Okay, then 2 factorial is just 2 factorial. Okay, and I have a 6 factorial over there. So what I can do over here is I can cancel out the 6 factorial. Okay, I can cancel out the 6 factorial. So over here I have an 8 times 7. 8, not 8.7, you see the location of the dot. 8 times 7 times 2 times 1, like that. Over 2 times 1. Okay, so this would be 28. Right, so this number over here is 28. Okay, now then for the 9 choose 5, okay, so it will look something like this. So it will be 9 factorial, so 9, I'm going to count down, times 8 times 7 times 6 times 5 factorial. Okay, let me just divide off the big one. So I have a 5 factorial in front and a 4 factorial behind. So technically speaking, I can just cancel this. Okay, cancel the 5. Oh, okay, cannot see. Cancel this 5 factorial. So I have over here 9 times 8 times 7 times 6 divided by 4 factorial. 4 times 3 times 2 times 1. So this one you can type, you can type in, slowly type in. So this will give me 126. So in the same way, you can double check your 9C5 should give you 126 on your calculator as well. Okay, so something like that. Okay, so let's take a look at try 2, right, at page 138. So the formula, I leave it up there for reference. Okay, so evaluate 9 choose 4. Sorry, this one might look okay. So evaluate 9 choose 4. So how does 9 choose 4 look like? So 9 choose 4, right? Okay, I think why not let's do calculator. Right, 9 choose 4. Let's not waste time. Let's just do calculator. So 9 choose 4 is going to be equals to 126. Because they never say cannot use calculator, right? Okay. Now for B, show that 15 choose 3 is that. So let me do this. So 15 choose 3, right? So it's going to be equals to, now I'm going to have a 15 factorial over there. Okay, maybe let me write this bigger a bit. Okay, so 15 choose 3, like that. In a big bracket, and then I have a 15 factorial on top. I need to divide by r factorial, which is 3 factorial, and 15 minus 3 is 12, so 12 factorial. Okay, so n factorial r factorial n minus r factorial. Okay, so like that. So let me just count this down to 15 times 14 times 13 times 12 factorial. Okay, let me just write it until 12 so that I can cancel with the 12, right? So once I see that, you know, I can cancel this, it will be very nice. So I will just leave it as 15 times 14 times 13 whole thing divided by 3 factorial, shown. Okay, so shown. So it's like that. Okay, so it's just mainly like, you know, counting down and then just cancelling for that. Okay. Okay, alright, so let's come to try 3, alright, the formula is up there. So now for try 3, it's a different ball game because previously we have definite numbers, we have like 9 choose 5, 12 choose 6, that kind of thing, right? But for this case over here, we have an n, we have an unknown there, and our calculator cannot compute unknowns, right? So this one no choice, we have to do brute force. So the thing about this is that we need to know this skill because when it comes to unknown n's, right, we may need to expand this ourselves. Okay, we may need to do this manually ourselves. So it's important to know this. Okay, so I think once you and the thing is that this formula will be given at the front page, so we can always refer to that. Okay, come. So let's do this. So we are given with n choose 5, right? Given n choose 5 is equals to an n choose 3, right? So let me just do this here so that, okay, more space. Okay, so what is this actually? So this is just okay, so n choose 5 means based on the formula, the top would be n factorial, the bottom is going to be okay, the bottom is going to be 5 factorial first, the r factorial, and the difference factorial, okay, is equals to n factorial on top. Now the r is 3, so it's divided by 3 factorial and the difference factorial, like this. Okay, now so the thing over here is, how are we going to do this? We are going, okay, so let me do an easy thing first. Let me okay, let me do an easy thing first. Let me expand the n factorial, okay, so that we can cancel on the left and the right. Okay, so I'm going to expand n factorial, so I have an n minus 1, n minus 2 times n minus 3 times n minus 4 times n minus 5 factorial. Okay, so this one, okay, I will put this on the left hand side like this. Okay, and the whole thing I will divide by 5. Okay, 5 factorial, let me expand this out first. So 5, 4, 3, 2, and 1. And I'm going to multiply with n minus 5 factorial. So the factorial part is the one where I want to cancel out, right? But the remaining one over there, just nice, I will just leave it there. Okay, then on the right hand side, I will have this. Okay, I have an same thing, n minus 1, n minus 2. Okay, I see an n minus 3 factorial at the bottom, so I'm going to stop here. Okay, so how do I know where to stop? Just look at the denominator, right? Look at what you want to cancel. Then the 3 factorial is 3, 2, and 1. Then I need to multiply with n minus 3 factorial. So immediately I can see that I can cancel n minus 5 factorial and n minus 5 factorial. I can cancel n minus 3 factorial and n minus 3 factorial. Okay, now next I can do more cancellation on the left and right. I can cancel n on the left, n on the right. I can cancel n minus 1 on the left, cancel n minus 1 on the right. I can cancel n minus 2 on the left, n minus 2 on the right. I can do that. Okay, at the same time, I can also cancel more things. I can also cancel at the denominator 3, 2, and 1. 3, 2, and 1. I can cancel these 3 things. Okay, so in the end of the day, what do we get? There's a lot of cancellation, but what do we get in the end? It's just n minus 3, n minus 4, right? Over 5 times 4. So this is going to be 20 on the left hand side. On the right hand side, the top fully cancelled, the bottom fully cancelled. So we're just left with 1, not 0, 1. Okay, let me multiply the 20 over to the other side. Okay, equals to 20, and let me expand. Right, expand. Okay, make into a general form because this is a quadratic equation. Then factorize. Right, factorize. So n is going to be equal to 8, or n is equals to -1. Right, so over here what do we do? Which one do we reject? We reject the -1. Okay, we reject the negative number because n is going to be a positive integer. Right, n is going to be more than 0. So that's why, yeah, okay, so n must be more than 0. Okay, so this is the way in which we use to expand when we have an unknown in the n choose something. Okay, we will expand as fractions and it will just cancel. So when you look at this, don't panic because the formula is given. You just need to know how to use the formula. Use it in an abstract manner because there's no fixed number, right? It's just n. But you need to be comfortable just expanding until you can cancel. So it's just a game of cancellation. In the end of the day, the problem is reduced to a very easy problem to solve. So don't worry too much about this, right? So listen up, so don't worry too much about this. Okay, so this is the key. Okay, so this is the key over here. So the n choose something, right, will be the second element that we need in order to form the to do our expansion in the second part. Now the last bonus that I'm going to give you is actually this Pascal triangle, right? The same Pascal who is the same Pascal who did the pressure thing. Okay, the unit of pressure is Pascal, right? So yeah, it's the same Pascal, right? Pascal's triangle. So I'm going to start with 1. Okay, I'm going to start with 1. Okay, and I'm going to start with 1 1 over here. Right, so it's like a triangle. Now then, how do I get to the next line is I have 1 on the outside, so 1 number, 2 number, the third line will have 3 numbers, and over here is a sum of 1 and 1. It's the sum of these 2 numbers. So this one will give me a 2 over here. 1 1 1 1 2 1. Right? So when we go to the next row, it's going to be 1 and 1 on the outside, right? And let's take a look at the sum of this one over here. Right? So the sum of 1 and 2 will give me 3. The sum of 2 and 1 will also give me 3. Okay? So 1 1 1 1 2 1 1 1 3 3 1. The next one would be a 1 and a 1 on the outside. So let's try to sum up and see. So 1 plus 3 will give me 4. 3 plus 3 will give me 6. 3 plus 1 will give me 4. So 1 4 6 4 1. Okay? Next one. 1 on the outsides, right? And how do we get this? 1 plus 4 is 5. 4 plus 6 give me 10, right? And 10 and 5 and 1. Okay, let's do 2 more for the fun of it. So 1, 6, 15, 20, 15, 6, and 1. Can you see this? Okay, let's do one last one. So 1, 7, 21, 35, 20, 35 again. Right, 35, 21, 7, and 1. Right? So let's take a look at some observations. So the ones on the outer ones are 1. The second term is the n. You realize, right? 1, 2, 3, 4, 5 is all running numbers. Okay? And do you notice that there is actually some sense of symmetry at the middle? Right? Some sense of symmetry at the left and the right. Okay? Some sense of symmetry over there. Okay? Quite nice. So actually this triangle is actually Pascal's triangle. And what is it actually? Yeah? It actually correlates to this number. So this number on top 1, right? Actually 0 choose 0. Is it? Yeah, correct. 0 choose 0. Okay, then the next number over here is 0 choose, no, sorry, is 1 choose 0. Then over here is 1 choose 1. Okay, so this is when n is equals to 0, when n is equals to 1. Okay, and the next one is when n is equals to 2. So this would be 2 choose 0, 2 choose 1, 2 choose 2, right? So this number is 2 choose 0. Okay, you can verify your calculator. 2 choose 1, how many ways to choose one object from 2? Just 2 ways, it's just either A or B, right? How many ways to choose 2 objects from 2? Only one way to do so. Okay. Now, let's take a look at the next one. So this would be a 3 0, 3 1, 3 2, and 3 3. So do you see that it actually makes sense, right? So how many ways to choose 0 objects from 3 objects? So just one way. How many ways to choose 1 object from 3 objects? 3 ways. How many ways to choose 2 gifts when you're given 3 gifts? 3 ways also, right? How many ways to choose? You take all of them, so it's just one way. So this is just n equals to 3. So building upon it, it will look something like this, right? 4 1, the number in the middle is 4 2, then 4 3, then 4 choose 4. This is for n equals to 4. Okay, so this is where we get our Pascal triangle from. It's actually building up the numbers to n choose r. Okay, n choose r. Okay, so something like that. Okay, now some things to take note also, right? So as you can see, n choose n over here. Let's take a look at this one. So n choose n, right? How many ways to choose n objects given n objects? There's only one way to do so. So from here, we have one result. So n choose n will be equals to 1. Okay. Now another result over here will be this one over here. How many ways to choose 0 objects? So n choose 0 is also one way to choose 0 objects from a list of n objects. Okay. Now the next thing over here is this one over here. Okay. So we have a 2 choose 1. Sorry, we have a 2 choose 1. We have a 3 choose 1. We have a 4 choose 1, and so on. Correct. So if you have a 2 choose 1, 3 choose 1, 4 choose 1, 5 choose 1, 6 choose 1, and a 7 choose 1. Do you see this? Right? So actually, let's say if you have an n choose 1, so this will be equals to n. Okay, how many ways to choose one item from a list of n items? Just n ways. And on the other side, because it's symmetrical, right? Because it's symmetrical, correct? It's symmetrical, right? So if this is n choose 1, this will be n choose n minus 1, right? So technically speaking, so this is also n choosing n minus 1. So this is also equals to n. So here we have 4 simple results, right? 4 very simple results from here. Okay, from like by just observing the Pascal's triangle. Okay, so mainly like that. Okay, so I think we will stop here for now. Okay, so let's recap a little bit. So for the first part of the video, we talked about the factorial notation, which means that it's a number of ways to arrange n items. So this is the first thing that we talk about, and some of the stars are the things that we need to know. Okay, then we talk about the n choose r notation, number of ways to choose r objects from n objects, right? So given n objects, how many ways to choose r of them? So we have a formula over there that I need to star as well, right? And we have some results at the end which involve Pascal's triangle. Okay, we have some interesting results over there. Okay, so this ends the first part of binomial theorem. Okay, in the second part of binomial theorem, we are going to talk about the expansion of the thing already. Okay, so hope you hang in there. Okay, I think for now you can start to clear exit past 6.1. Okay, based on what we've learned. Okay, so that's all for this lecture and this lesson. I'll see you at the next one. Okay, bye bye.